Hi and welcome to Home Assistant How-To with Bearded Thinker. Today we will be revisiting our old plant HiGrow sensor board. We'll start in a couple of seconds. Before we begin today's episode, I really would like to thank all the members who have joined my channel. Thank you very much, your support is really appreciated. And now, let's get started with the video. It has been around 9 months since my last video about LilyGO HiGrow board plant sensor. Then, Pesor released a new firmware that allowed us to use MQTT on these boards and to embed it inside Home Assistant, or really any other home automation software that can be attached to MQTT. Since then, Pesor did a lot of changes, and we are currently on the firmware 4.3.1. That has brought a lot of improvements, but also it has changed the way how we work with the firmware. And because of that, I'm recording a new video that shows you that it's really easy to convert from the Arduino IDE to VSCode with PlatformIO. So today, we'll be revisiting the code, implementing the latest version of firmware. I will be guiding you through all the steps, and also we'll be talking about some differences between the boards that are currently on the market. And yes, all those boards are supported with the latest version of firmware, including the external temperature sensor. So let's get started. There are a couple of steps for this. We will start with installation of VSCode, and after that we will also be downloading and installing PlatformIO inside the VSCode. If you already have those installed, you can skip to the second step. After we install this software, the next step for us will be to download the latest firmware or the code for the firmware. We then have to change it, calibrate our board, and upload the board itself. The last step will be to enable this board inside our Home Assistant. Okay, let's get started. As a first step, we have to download Visual Studio Code. If you already have Visual Studio Code installed and PlatformIO extension inside Visual Studio Code, you can skip to the time mark that's shown on the screen. I will be downloading a Windows version since I'm installing this on the Windows machine. In order to do that, just press on the download for Windows. After the file has been downloaded, click on the file to open and install it. Accept the agreement, next, install. Now let's press finish and we will also launch our Visual Studio Code. Next step is to click on the extensions. This is this button. Type here platform and click on the PlatformIO IDE. Current version at the time of recording is 2.3.0. Just press install. And how will you know that PlatformIO has been installed? The new icon will pop up here. Let us press on this icon. The next step for us is to go to GitHub repository and download the latest version of the code for our firmware. There are a couple of ways how you can download the code. One is to press on the down arrow here and select Download Zip. The other option is to go to Releases page and there download the latest release version. As I said, at the time of the recording, the latest version is 4.3.1. Let's click on the source code and it has been downloaded. Extract to the folder of the same name, and we will go back to PlatformIO in VSCode. In a PlatformIO, click on Open. This will open the main screen. Open Project, and go to the folder where you have extracted those files. For me, this is Download folder, and here we have LilyGO HiGrow 4.3.1 folder. Inside the folder, there is a file called platform .ini, and we will open this folder. The project is now open. As you can see, all of the files from the project are here, but we will be needing just one of those files, user variables.h. This is the file that contains all the variables needed to configure and make the board work inside your system. Although normally you would go from the top to the bottom, this time I will be going from the bottom to the top to configure it. Let's scroll down. At the bottom of the file, first thing you have to set here is the broker. This is the IP address of your MQTT server. For me, this is 192.168.1.35 with the default port of 1883. In a case that your system, MQTT system, uses username and password for authentication, you have to specify them here. User, let's say it's HASS, and the password SSAH. You can leave device name as is. If you want to adjust your time zone, correct this GMT offset that is in seconds. Remember, each hour is 3600 seconds. So adjust this either with a negative or a positive value. Next thing is the NTP server. I would really suggest that you leave it as is. Next step is to configure your Wi-Fi connection. In this example, we have 4 SSIDs or Wi-Fi names. You can use one or multiple Wi-Fi SSIDs. For the purpose of this video, I will be using only one, and it will be called BT IoT2. Depending on how many Wi-Fi networks you have configured, you have to adjust this number. Currently, it is for 4 Wi-Fi networks, but since I only have one, I will type here 1. For the Wi-Fi password, you have to change this line here. Password equals your Wi-Fi password. Okay, we have now prepared our code to successfully compile. Now it's time to configure it. Depending on the type of the board, you have to select either DHT11, DHT12 or DHT22. I haven't seen HiGrow boards with the DHT22 in a long time, so you're most probably using either DHT11 or DHT12. I, myself, have boards that have DHT11. And that's why I will uncomment this line and comment out the line with the DHT12 sensor. And how do you know what type of sensor you have? Well, just look at those images here. The sensor on the left side is DHT11, while the sensor on the right side is DHT12. After you have selected sensor here, you have to change this to true, because we have DHT on board. If by any chance you have a new board that has neither DHT11, 12 or DHT22, you can leave any sensor selected here and change this to false. And false is of course also a default value. So if you are using BME, leave this false. If you are using either of the DHT sensors, type here true. We have now configured our temperature and humidity sensor, and in case of BME also pressure sensor. Now we can specify or select if we have external sensor or not. External sensor, such as this one you can see here, is a sensor that is optional sensor and it can be hooked up to the HiGrow board. If you are using external sensor, change this from false to true. In that way, you will be telling the board that you have enabled this sensor and it will be also collecting information from that external sensor. If you do not have external sensor, or you will not be using it, set this to false. We are almost done. The next step is to calibrate the board. And for this, what you need to do, you need to hook up your board with the USB cable to the computer. The board itself has to be clean and dry, meaning that it cannot have any water on it. And the first step, in order to get the maximum value, will be for us to click on a PlatformIO and click on Upload and Monitor. This step will now compile and, if needed, download any libraries. You may see some warnings, but unless there is an error, everything is okay and you can ignore them. When the compiling of the firmware is finished, the firmware should be automatically uploaded to the board. And you will see that with the progress bar shown on the screen, such as this one. After the upload is finished, the board will try to connect to our Wi-Fi, and we should see information about that on screen. The board has connected, you can see the MAC address here and the IP address it received. And now the board is giving us or providing us with the values. And currently we are looking at one value, and this value is soil before map. This number we have to input here, 3167. In order for us to get the minimum value, you need to have a glass with the water and carefully insert the sensor board into the water, but without touching electronics with the water. So be careful. Only the lower part of the board without any components has to be in the water. And we just press once again at Upload and Monitor. And the value is 1493. We will replace this value with the value we received, 1493. You can remove now board from the water, which I just did. Dry it out just to prevent any water reaching the electronics. And now we will change this to true, because we want to save those values on the board. And by doing this, we will be retaining those values even when we install the new firmware. And while we are already doing that, we will update plant name and change it to something else, such as rose. We'll press save. In the future, you will be also able to use and combine this board with the greenhouse watering system. And if you're interested in that, you can subscribe to Pesor's repository and check development there. Now we have to save calibration values and the name of the plant, so I will be once again uploading and monitoring the boards. And we are now done. The board is configured, and if you have a battery and the battery is charged, you can now unplug the board from the computer and insert it in the flower pot. And now that everything is prepared, the next step is to add the board itself to the Home Assistant. The easiest way to do it is to use autodiscovery. In this video, I will be only covering one way of how to add them, and I will be using my Synology for that. And in this process, we will need two files. This one, which is a Python script, and a sensors YAML file that we need to put inside the sensors folder. To shorten everything up, I'll open up this file, select everything and copy it. And now I will create this same file on my Synology. Inside Home Assistant, you should have a folder named Custom Components. If you do not have any custom components so far, just create a folder called custom_components. In this custom components folder, create new folder, and I will call it HiGrow. Let's open this folder, and here we will paste the file we copied from our Visual Studio Code. Text editor, new file, and this is the whole code that I copied from the Visual Studio Code. File, save as, Home Assistant, custom components, HiGrow. This is the file name. You can of course call it something else too. Let's save this. The next thing, in this same folder, we have to create new subfolder called sensors. And inside this subfolder sensors, we have to create sensors.yaml file. If we look at the content, we have to copy those 4 lines. So Control A or select everything, press copy in a Synology, new file, paste everything, and save it as Docker, Home Assistant, custom folder, HiGrow, sensors YAML, and the name of the file will be sensors.yaml. Save. This part is now done. As I said, there are multiple ways on how you can run autodiscover for the MQTT in our board. For me, the easiest way, since I'm always using Synology, is to run it directly on a Synology machine. But in order for you to run it, you need to have Python 3.8 version installed. This one is Syno community package. Let's close this. And now I will use terminal to connect to my Synology machine. Build it. Password. If we would type Python here and version, we see that we are running version 2.7.12. So in order for us to use the Python 3.8 version that we have installed, we have to run it from folder where it is located. And this is volume 1, App Store, Python 38, bin. And we have to run command Python 3. And let's check here the version, if everything is okay. This is Python 3.8.7. So we now have on our Synology both 2.7 and 3.8 version of Python. And as I said, we will be needing this 3.8 version to start the script. But where is the script? Let's go to volume 1, Docker, Home Assistant, custom components, HiGrow, and here is the script called ttgo t higrow auth.py for Python. But not everything is done. If you now run the script and you haven't installed paho MQTT client, you would receive error. And what error? Let me show you. ttgo t higrow auth Python. As you can see, we are missing paho MQTT client. But that's no problem. If we use pip3 install, we can install the module. For that, I will just borrow this line, type here pip3 install paho MQTT and press enter. Everything installed. Let's copy the previous command and let's try to run the Python script now. Okay, it now says that it has no route to host. And the problem is that we are using the wrong IP address. Well, that's also easy fix. Let's go back to Synology or any editor to edit this script. Let's open up this script. And let's find here IP address. IP address for me is .35. And if you are using username and password, you have to fix it here. But if you're not using them, you can comment this out. Let's save the script. In terminal, let's run this command one more time. As you can see, it looks like everything is added. I will press Ctrl C and I'll go back to Synology. Let's close this and let's look at sensors file. If we look here, we can see that the latest board that was added is called Rose 1. And this is the board that we flashed the latest firmware on. Okay, let's close this. And let's go to Home Assistant. In Home Assistant, Configuration, Integrations, MQTT, Rows, you can see here that we have a new entity called rows with the firmware 4.3.1, battery, boot count, charging, date, fertilizer state, fertilizer percentage, humidity, lumen, MAC address, pressure if your board has BME 280, firmware release, sleep count, soil percentage, soil temperature, if your board has external temperature sensor, room temperature, time, there was a last update, to what Wi-Fi network it's connected, when the battery was charged, how many days since your battery, and to what greenhouse valve it is connected. And that's it. Last step for you would be to create a plant sensor integration, where you would have a nice visual representation, such as this one here, or any of those. And this is it. The plant board is now integrated inside Home Assistant, and we are pulling information from the pot or the plant itself every 1 hour, at least in my case, because these are the default values. You can of course tweak the firmware and change the interval when the board is updating and giving you new and fresh information. As you can see, not much has changed, but in reality a lot has changed. Adding the board itself is much easier by using autodiscovery than, for example, to add every single sensor from every single board by hand in a configuration YAML file. Also, as you can see, the editing of the firmware is also much easier. The ability to save calibration data and the plant sensor in a permanent memory, so that when you reflash the board you don't lose that, is also a great addition to the firmware. And I really want to thank Pesor for this. Thank you. And this is it for this Home Assistant how-to with Bearded Thinker. If you have any kind of a comment or a question in regard to this video or any other previous video I made, you can always find me on the Discord server. The link to Discord server is in the description of the video. But also feel free to leave the comment down in the comment section below. If you still haven't subscribed, please subscribe and hit the bell button so you get notified on the future updates, and I'll be seeing you next time. Until then, bye bye and have fun.